Well, hey out there and welcome. This is absolute value and we're going to do a little bit of a brief intro what absolute value is, and then we're going to talk a little bit about radicals, and that's probably good enough for what could be the very beginning of this course. So I'm going to go to the number line here. Okay, so I'm going to mark down 0. And suppose I said to you, the number 3, what does it really represent? What does it mean? Well, let me just show you on the number line. There's the number 3. And what the number 3 represents is from 0, a distance of 3. And because it's positive 3, it means over to the right. Now, what does negative 3 mean? Well, on the number line, it means we're over here. So we're a distance of 3 away from 0 on the left. Okay, so it's kind of like when we say negative 3, we give a bit of direction with it. And we say positive 3, we also give direction. Now, what absolute value is all about is saying, forget about direction. What's the distance? You know, just how far from 0 are you? And that's really what absolute value is saying. So if we said the absolute value of 3, okay, and these straight lines here, these vertical lines, straight lines, that's the absolute value symbols. And it means, okay, what's the absolute value of 3? What is the distance from 0? Well, the answer would be, we're 3. And the absolute value of negative 3, well, guess what? That's also 3. You know, that's the distance away from 0. So if you think of it in terms of distance, it's a pretty easy concept. So as an example, I could throw at you negative 12. What's the absolute value of negative 12? Oh, that's just 12. Okay. Now let's be careful. Sometimes students run away with this and they go, well, what about that? Okay. All right. Well, what you got to do here is you got to go and do this evaluation first. You got to figure out, well, what's inside here? Negative 2 times 3 is negative 6. Okay, so you're saying the absolute value of negative 6. Okay, well, that's just positive 6. Okay, remember to work this stuff out first. Let me just show you where sometimes students can get and make a mistake. Say you had something more, little bit more to it here. Say you had all this going on. Okay, don't do anything with these negative signs first. First things first, you want to evaluate what number is inside here. So this is negative 4, and then minus a negative 2, or effectively plus 2. So negative 4 and positive 2, oh, that makes negative 2. So what we're really saying is we want the absolute value of negative 2. Okay, so that's positive 2. All right, so you see how I worked all this out first, and then I got my number, and if it happens to be a negative number, then I turn it positive. If it was a positive number, it would stay positive. Just be warned, sometimes we get fooled by something like this. Okay, so you might look at that and think, oh, absolute value is always positive, and yes, it is, because we're going to absolute value negative 4 here, so that turns into positive 4, but wait, this isn't in any absolute value symbols here, so that negative sign is still out there. So this is actually going to be negative 4. Okay, that's about all I want to say about absolute value right now. I'm going to take a little bit of time to review radicals, and then we're going to call it a day. Now, radicals are a way of taking information like 3 squared equals 9 and expressing it in a slightly different way. I'm going to use this symbol here, the square root of 9, which equals 3. This is called the radical, right? So, as opposed to over here where there's no such symbol. And so we can quickly figure out things like, let's see, if we knew, say, 4 cubed is 64, then to express that information with a radical would look like this. The cube root of 64 is equal to 4. Okay, or let's see if we got another nice friendly one. Let's take something like maybe 3 to the 4. We know that 3 times 3 times 3 times 3 is 81. And so writing that as a radical would look like this. The fourth root of 81 would equal 3. Okay, it's the same information being shown again. Okay, let me just do one more complicated example that uses some variables in it, and then I think we'll call it a day. So cube root of, let's throw at you negative 64, and maybe x cubed. Okay, I often think the easiest way to unravel this stuff is to look for 3 groups. In other words, wouldn't it be easy if I could figure out 3 identical groups, all of which are equal to negative 64x cubed? Now, why 3? That's because this is asking for a cube root. So I could look at the numbers and go, how about negative 4 times negative 4 times negative 4? Yeah, that's going to give me negative 64. Now, what about this x cubed? Well, why don't we throw an x in each of these little bundles here, okay? So I go, oh, I know what's going on here. The answer would be negative 4x. And that's because, and this is kind of a way of checking, is negative 4x cubed give me negative 64x cubed? I think it does. I take negative 4 and I cube that, and I get negative 64. And then I got x cubed. So yeah, it's doing what it's supposed to do. So we checked it. Looks good. And that's where I'm going to stop with our little introduction here. So we'll talk to you later when we got more new exciting stuff.